Okay, so now I'd like to switch gears a little bit, and I'd like to ask you to analyze data. It's the same type of data, so the invisibility RM data is about wearing a cloak and not wearing a cloak. The spider RM data is about seeing a real spider or seeing a picture of a spider. So we're still in that same design, that same mentality. But here's a huge difference, and this is why there's actually a separate spreadsheet. So if you remember in this invisibility spreadsheet, we had to have one column with the cloak, a 0 meaning they did not have one, and a 1 meaning they did have one. And then we had another column for the mischief. And so all of mischief was in the same column. And that made it really nice and easy to look at mischief in a histogram, in a box plot, to come up with standard deviations and means. I could come up with standard deviations just for this group and just for this group, or I could come up with my standard deviation for the whole group together, and that's the standard deviation I used in the effect size. So there's a reason that it's set up this way in SPSS. But imagine this scenario, and it's a good one. I'm going to close the spreadsheet because now we're moving to the invisibility RM. RM stands for repeated measures. And so this allows us to control for some of that variation. In the independent sample, we had this group with the cloak and this group without the cloak. And these two groups were independent. They didn't know anything about each other. But I can almost promise you, just because I know my own children, in each group there are some who are very mischievous, period, cloak or no cloak, and there are some who would never get into trouble, cloak or no cloak. Well, what if we could match those people together? Even better, what if we can give each participant, let them go a week with a cloak, let them go a week without a cloak? So that's how this data is set up. Here's participant number 1, little Johnny. During his week with no cloak, he had 3 acts of mischief, and during his week with a cloak, he had 4. Well, now we're comparing Johnny to Johnny, and we don't have to worry about whether or not he's a mischievous child or some of his personality traits that might be confounding variables. We get to compare Johnny to Johnny. One thing I hope Field did in this, and you can imagine, is to do some randomness in terms of some people had the cloak their first week and then no cloak the second, and vice versa. Some people had no cloak the first week and their cloak the second. That would make this a stronger study. So let's assume that's what Field did. But now he has to set the spreadsheet up very differently because he wants to make sure that person number 1's no cloak result is matched with their cloak result. Because now we're going to run a matched, paired, dependent, meaning these two results are dependent on each other. There are several words for this test, or even repeated measures. That's what the RM stands for. In other words, we measured Johnny with a cloak, and then we repeated the study without a cloak and measured Johnny again. And here's number 2, Susie, and here's number 3, Betty, and here's number 4, Freddie. And we've got each person repeating the study under different conditions. It's a powerful study. And so I just want to show you quickly, we're not going to worry too much about what Field does until we come to page 383. You can try these other graphs if you'd like. I think they're fantastic. But for our purposes, for the homework, I would just like you to be familiar with this test and how it can be different. Some of you may want to use it. This is a fabulous way to analyze pre-test, post-test results. Okay, so we just come in here under Analyze. We come down here again, we're comparing means, but now instead of the independent samples, we have a paired sample. We can pair these results. We can pair Johnny's results. We can pair Susie to Susie, Betty to Betty. We can compare each person within themselves. So for pair number 1, I'm going to put mischief in for variable number 1. It doesn't really matter which one you put in first. You may have a positive or a negative t-value, but the value will be exactly the same, and that's all that matters. Okay, I'm just going to click OK, and here is my output. Here again, my means are the same, right? My standard deviations are the same because Field put in the same numbers. He wants you to see how things change. But now SPSS gives me a correlation. See that correlation of 0.8? We are now going to use that as our effect size, which is very cool. So we don't have to go in and calculate an effect size by hand. And then down here is our paired samples test. Now we don't have to worry about the equality of variance anymore. So notice Levine's test is not here. And then in the next video, I'll show you how we'll write that up. So that's the invisibility data set, which is in the textbook. I would just like to quickly run the spider data set with you so that you feel comfortable with that. So once again, I've got my spider data set open. I'm going to come down to paired samples t-test. I'll put picture of spider in here for variable 1. Picture of spider, real spider in here for variable 2. Okay, and I'll click on my results and excuse me, I'll analyze this right here. I'm not exactly sure. Oh, my results will be here behind in my output. Okay. Here are my spiders. So once again, we have the same means, the same number of participants, the same standard deviation. So Field used the same data, but he paired each result. Here's our correlation, 0.545, so a moderate effect size. And then here is our significance, okay? And we'll talk about this in the write-up, but look, it's 0.031. When you compare people in a test, it's so much more powerful. All right, well, have fun with this, and thanks for watching.